thank you for joining to this session. So this is my name is Katsushi Shindo from NTT, so NTT headquarters. So in this session, so Marco-san and I would like to talk about one of the key pillars of IOWN. So All-Photonic Network APN and distributed data center infrastructure with the APN. So first of all, so I heard very happy news this morning. So we announced that we have successfully demonstrated low delay communication over the less than 1 millisecond between the data center owned by NTT groups, so located at about 100 kilometer distance from each other, so using the ION APN. So Marco-san will share more information about this press release later. So NTT Group is the world's third largest operator in the data center market. So in particular, so in India, so it is the #1 data center operators. So NTT Group has data center in major locations around the world. So in addition to providing the network and managed service, so NTT Group already offer data center in the several regions to meet the demand for AI and LLM and also. So this slide shows the challenges facing the world data center. So as this slide shows, the amount of data processed in the world data center is expected to grow rapidly. So computer power required to provide that data will also increase rapidly. So NTT, which provides the data center service worldwide, so need to reduce the power consumption and contribute to the sustainable society. So other challenges in data center business. So recently, so due to the large amount of power consumption and land shortage, so it has become difficult to build a new data center in the urban area. So forcing the customer to data center in the suburbans. So we are connecting the data center over the long distance. So the delay of the communication between the data center can be very high, so make it difficult to meet customers' need for low delay connectivities. So we are NTT are solving these challenges by utilizing ION APN. So ION APN so offer the value of the high capacity and high quality communications, low power consumption, and low latency. So this enables customers to meet their needs in use case, whereas low latency is highly so required, so such as real-time AI analysis and in the financial sectors. So now, so I would you to see a video so about connecting the data center using the APN.
As society becomes more data-driven, the demand for data centers increases. But two challenges stand in the way of building new facilities. The first is the lack of land inside cities where data centers can be placed. The second is that data centers installed in the suburbs, where land is available, lead to high latency and low network performance. The All-Photonic Network, or APN, will solve these two issues. Conventional networks require photonics-electronics conversion of optical signals to electric signals for each optical line, which leads to unavoidable latency problems. APNs, however, do not use photonic-electronic conversion, resulting in high-speed communication delivered through optical technology. APN-equipped data centers will not be affected by communication delays due to facility location like today. APNs also have numerous cost advantages. Conventional optical transmission networks require expensive, full-function equipment installed at each location, leading to increased costs. APNs can be optimally deployed depending on function and scale, keeping costs low. APNs also consume less power as they only process light. Plus, promoting the dispersion of data centers in suburban areas will result in the consumption of local energy. IOWN's mission of contributing to a data-driven society while remaining carbon neutral will continue on.
So as mentioned in this video, so ION APN can connect it data center and create the unified IT infrastructure that allow urban and suburban areas, so data center, to be used as if they are some data centers. So NTT and NTT DATA groups and the business unit worldwide planning a joint demonstration with their customers in the financial sector and other use case areas. So for the distributed data center to launch business soon. So we will confirm with our customers that a distributed data center with ION APN connection can fully meet the requirement for the actual business operations. So from here, so I would like to ask Marco-san to talk about our demonstration in the London, so using the ION APN, so between the data center. So Marco-san, please.
Thank you. Thank you. So good afternoon, everybody. And thank you, Shindo-san, for that. So basically, we wanted to demonstrate that because, as you probably understood, IOWN, it's a concept started more than 5 years ago. The plan for developing that, it's pretty long. And now we start to see the results of this research. And we start to see the first bricks for the development of what is the vision of the full photonic network with all the technologies on top of that. So what we wanted to demonstrate is to be able to apply what we already have now, which is a conversion from electronics to photonics. And the first use case we're able to implement is, as Shindo-san just explained, it's about connecting data center together. That is what we've been talking lately. And basically, the problem is being able, or better, the solution would be to be able to expand the radius where you can interoperate between data centers. Let me just say, I mean, cloud is not really existing. Cloud is someone else's computer. So if from a user perspective, this might not be a problem. For those who manage the infrastructure and the data center, that it's actually changing. So basically, we wanted to demonstrate to be able to communicate, make an intercommunication between different data centers that are within 100 kilometers in less than 1 millisecond. 1 millisecond, it's a measure that basically helps us in understanding if we can distribute calculation, just like the use cases we've been, Vito's been talking in the speech before. We want to demonstrate that the jitter, which means the fluctuation, can be fixed and within 1 microsecond, and we want to preserve the bandwidth, basically. And that's what we did, and today, actually, you can find in the press a press release that talks about that. Actually, we've been experimenting in 2 use cases, one in US and one in UK. I'm going to talk about the UK use case. As NTT, we own 2 different data centers. And the interesting part of that, these are the 2 data centers, is that there are some mission-critical applications that might leverage the solution immediately. One example above all is financing sector and trading. If you do trading, you need to be fast as possible. So now latency and bandwidth in this context might be a problem. And that's why the companies that do trading tend not to use managed services from the hyperscalers or from remote data center, and they prefer to have a data center below their building, basically. Every millisecond is crucial in that context. London is the right city for financial services deployment, I would say, talking about infrastructure. So what did we do? We basically changed the gateways to the data center. You can see, basically, we substituted this 2 pieces, which actually are 3 pieces per side. And what we did is we moved from gray light, so standard fiber optic communication. We transformed that with a photonics, electronics, photonics converter, and with a multiplexer. We fired that with different colors, 100 kilometers on the other side of London and back. Just to give you an example, it's just like changing different type of flights or basically having priority boarding in very big airplane. This is what we did, basically. So switching from electronics to photonics helped us actually to have this metering. Actually, this in metro means that instead of measuring from here to here, we're actually measuring from here to here, which means that we're actually able to demonstrate the value. And the value of this is that we're basically reaching the maximum speed possible. So we're very close to the limit that the light gives us in the communication between site and site. Why is that so important? Because basically for us and all for those who works in the domain of data centers, this helps in thinking differently the infrastructure. Just like the example we've been hearing before, you have data, you have GPU. Today, you tend to have all those things in the same place. Now it looks reasonable to imagine that we can distribute load, computing power, data, and processing. So this, again, this is a vision, and the last thing I would like to focus on is how to implement that. This is not a big bang. This is incremental. We're going to deliver and to deploy many different IPs and solutions in the next years. So what we demonstrated today, basically, it's the point number 1. So an enterprise can connect through an APN, through an All-Photonic Network, to services that are remotely located in a data center. The second step would be to connect data center within a network. And what you see in the third part of the slide, it's a connection between data center. We call that APN, but as you can see, the lines are black. They're not yellow. It means that they're virtual optical fiber. It means that you don't need to have a spaghetti connection between everything with optical fiber, because the speed, it's enough for guarantee basically a connection between all of that. So this, again, this is the first little step in demonstrating what is the roadmap of IOWN and how this is going to change the way we think and we sell and we buy and we work on infrastructure, data centers, and managed services in general. So thank you very much for listening, and I'll leave you the floor for the next.